Hey there, how are you? Today we'll talk about nanotechnology. Do you believe in materials or things that you cannot see with your eyes? Nanotechnology is exactly that. Is a science that works on a level that we cannot see things. We need to use tools with high resolution to see what is in a scale of nanometers in a molecular level. We think in this science, and it's a multidisciplinary science, and this science was born in the 50s, and it's getting stronger and gaining momentum in different countries. So, since 2000, this science is studying different materials and it's studying and learning more about these materials so they can be applied in different types of products in different areas. So these findings are more and more common in the modern world, and today I like to invite Dr. Juliana from the CINBAN, that is the National Laboratory of Nanotechnology. She's a researcher and a specialist to talk about this transformation of materials in a scale where we cannot see things with our eyes.
Well, thank you, Renato. This is a field. Nanotechnology is a cross sectional science, as you have mentioned, a multidisciplinary science. It goes from medicine to electronics. It can be applied in different fields, and what is behind nanotechnology is that the materials and devices that are used in nanotechnology, one of the dimensions is in nanoscale. So you have an idea of the scale. 1 nanometer is 1 billionth of a meter. So a strand of hair is in the micrometric scale. The nanometric scale is 1,000 times smaller than the micrometric. And to reduce that much the size of the materials, we think about a very small scale that will require more sophisticated methods for the production. These materials can be produced on the bottom up or top down method. So we can break the materials until we get to the nanometric scale. We want to get to these very small materials because when we break down and decrease the scale of these materials until we get to the nanometric scale, the surface area that these materials will interact with the environment is going to be much smaller, much larger. I will give you an example. Liquid cellulose fibers are used to reinforce plastic. So you get the plastic mixed with the fibers and give it a mechanical property that is better for the material when we mix with a micro or micro fiber. So if we can break down this fiber until we get to a nanometric, very thin scale, the contact area between the plastic and the fiber will increase a lot, and it will probably increase the rigidity, the sturdiness of this material. As I talked about fiber, Renato, can you tell us about nanocellulose and the scenario to produce nanocellulose in Brazil and in the world and clubbing?
Sure, my pleasure, Juliana. It's so good to know and having you with us today. But talking about nanocellulose is one of those materials that is in this world of nanometric, world of nanotechnology. Nanocellulose is one of those products that we are using here in Clavin. And where does nanocellulose come from? It comes from the cellulosic fibers in the tree, in the woods, and it's the raw material for all the packaging and papers that Clubin trades. So with all these materials, we are studying different ways of extracting nanocellulose from those fibers and use this potential in
É
different
muito
products that we
interessante a
use today
gente
in the
entender
company.
que a
It's very
nanotecnologia é um
interesting
material totalmente
to understand that
sustentável e renovável, porque ele
nanocellulose
vem
is a
das
fully
fibras
sustainable
da
and
madeira, né?
renewable
E como a Juliana comentou,
element that
existem
comes
vários
from the
tipos de
fiber of
nanocelulose.
the
Hoje
trees,
eu
and
queria
we
dar
have
dois
different types
exemplos
of
aqui: a
nanocellulose.
celulose
I like to bring
microfibrilada
two of
e a
them:
celulose nanocristalina.
microfibrillate
Então,
cellulose
esses
and
tipos de
nanocrystalline
nanocelulose são exemplos
cellulose.
dos materiais que
These
a
two
Klabin vem trabalhando,
nanocelluloses are
né, como
part of the
materiais
materials
para
that Klabin is
incorporação em
working on
papéis e em
as
outras
part
áreas também.
of
Hoje,
these materials to
atualmente,
be
no
part
Brasil e no
of
mundo,
some
existem
other
vários
products.
produtores de
Today in Brazil
nanocelulose
and in the world,
e
we have
também
many
instituições,
producers
pessoal,
of
que pesquisam
nanocellulose, and
a
we have many
produção e a
institutions
aplicação desses
that are
novos materiais em
studying the
diversos
production
produtos.
and
Todas
the
aquelas
uses
áreas ali que
of
a
these
Juliana comentou.
elements in different
Hoje,
products in all the
atualmente,
areas
a
that
Klabin
Juliana
ela
told
tem
you
uma
about.
planta
Today,
piloto de
Klabin
produção de
has
celulose
a
microfibrilada.
pilot
Uma das
plant
nanoceluloses, né,
producing
que
microfibrillate
existem no mundo e
celluloses that
também
we
uma
have today
parceria
is one of the
grande com uma
different
startup israelense
nanocelluloses that we
para a
have,
produção
and
de
we have a
nanocristais de
startup
celulose,
from
que é uma outra
Israel that is
categoria de
helping us to
nanocelulose.
produce
Então, como vocês perceberam,
microcrystals
existem
of
vários tipos de
nanocellulose. It's
nanocelulose e isso
another
depende dos
category, but
métodos
it's a really
que esses
interesting one.
materiais são
So we have
produzidos,
many
né?
types, but it
E
depends on the
dessa
method
forma,
that
então, a
we use to
Klabin vem
produce them.
explorando o
So in this
potencial
way,
desses materiais que são
Klabin is
derivados do
taking
maior do
advantage of
polímero
this
mais abundante na face da Terra, que é
um,
a celulose,
element,
o
and it's
polímero
one of the
sustentável
most
e
common
renovável.
sources that we have is
Falando um
a
pouquinho então
polymer
desse
that is
posicionamento
available
da
in the
Klabin, a gente
nature, the
sabe que as
trees.
aplicações para a área de
So
papel
taking
são muito
into
grandes.
account the
Mas eu queria
positioning of
saber
Klabin, we
então,
know that the
usar com a
application
ajuda
is
da
very,
Juliana,
very
quais são as outras
extensive.
aplicações e o que
But
mais a
what
gente
are
pode
the
fazer
other
com esse
applications for
material.
nanocellulose, Juliana? Can you tell us a little about?
Right, Renato. Nanocellulose is quite recent. The study of the use in the literature, both the scientific and patent literature, there has been an exponential increase in the last 10, 15 years, both in papers and patents that have to do with the production and application of nanocellulose. And why are people so interested in this nanomaterial? We see companies and research institutions interested in this nanomaterial. In addition to having the properties of nano uh, materials, increasing surface and reinforcement, nanocellulose has low toxicity, different from other nanomaterials. That's why we see applications of nanocellulose in different fields: food and fabrics and fashion. I am going to tell you what we've been doing at CNPen with regards to the application, an academic study to help companies take this nanomaterial into the market. We've been studying a lot the use of nanocellulose in dispersions that simulate formulations such as black beauty products. The fibers, they look like a spaghetti and they interlace in the dispersion, giving it good emotion for water with small additions in the dispersion. That's very interesting to replace in the cosmetic industry the emulsifiers that come from oil or for the other application we've been studying for nanocellulose is its use to stabilize emotions. When we have water and oil, for example, nanocellulose acts in the interface between water and oil and decreases the tension. So you can form an emulsion and you can replace detergents that many times are very irritant to skin. So in addition to that we've been using in the lab, we put other components. We see how it's the behavior of those fluids, and we've been using nanocellulose to produce adhesives. We developed an adhesive that is nanocellulose based, and it has wet substrates, and it uses different substrates, and it's water based. So these are some of the applications we've been studying in our lab. But thinking about the future, we want the nanomaterial to reach the market. So we still have many challenges. we still have to study a lot to make this available for different fields. I'm going to tell you about some of the challenges that I see in my research, and maybe Renato also sees that at Klabin. First has to do with the production of nanocellulose. For you to get to the nanoscale, we need drastic conditions. We need mechanical process that use lots of energy, or we need high concentration of acid to produce the nanocrystal, which is the other material showed by Renato. So we still need a lot of research to develop techniques that are greener to produce these nanomaterials. In the lab, we didn't use eucalyptus, we use the sugarcane bagasse, and we saw that we didn't need to use the mechanical process for the production. So studies that combine a change in the chemical and enzymatic changes, they are interesting, so we can get to greener process that can be scaled. The other thing is that nanofiber, nanocellulose that I work with, when it's in the water, it forms a gel, which is very good in the application for the cosmetic industry. But to transport this nanofiber, it's difficult because it forms a gel, and if we remove water from this gel, the fibers get together and they cannot be dispersed, and I cannot get the viscosity that you get for the nanocellulose. So studies to assess methods that are able to dry nanocellulose, they are interesting because then they can be transported as a powder. Thinking about the application, there are studies in our lab in the production of foam of nanocellulose. This can be used to eliminate water, or to it can be used as a thermal and acoustic insulation to replace polyurethane, but the production requires a drying step, and this step is still very expensive. So we need to evolve in the drying process for the nanofiber so we can keep the structure of a foam. So this is an example in one application of what we need to do to make this nanocellulose available in the market. What about clubbing? What are the challenges you are facing to make nanocellulose go beyond?
Yeah, well, that's really interesting, Dr. Juliana. You gave us some examples of real challenges that we have in that area, not simple thing to solve, and we know that things are becoming more and more popular, and it's important to bring this material out of the lab and take it to the real world to become real product. So yeah, clubbing now with the investment, the company in the pilot plant, which is just beside our innovation technology center, we are investing since 2019 in microfibrillate cellulose and the application of this product in papers and packaging solutions that Clabin sales. So all the different products are in the lab scale, but they are becoming reality step by step. And we know that with this nanocellulose in the paper structure, we can reach unique properties not only from paper but also in the packaging sector. So we can have more resistance, we can have better properties on the surface of the paper, so we can maybe create materials that can serve as barriers for oxygen, for fat, for other molecules. So we are investing a lot in nanocellulose to modify our portfolios. But not only that, besides that, we are giving a new meaning to the packaging solutions, and we want to help every day with new solutions and new applications. As Dr. Juliana showed you, we have many possibilities, many potential uses
Muito
of these
legal que esse
materials. And
material
a very
é
interesting thing is
renovável
that
não
this is a
só.
sustainable,
E como ele
renewable,
está muito disponível e é o
non-toxic
principal e
material.
vem da
It's
principal
highly
matéria-prima da
available and
Klabin,
it comes from the main
a cada dia a gente vem
raw
tentando,
material
além de
from Klabin,
incorporar o
the
negócio
main
atual,
supplier.
tornar novos
So
negócios
we try
realidade,
to
né?
create new
E esse é
realities,
um
new
dos nossos
business
desafios.
opportunities. And
O
that's one of
principal
our
desafio
challenges.
é
The main
fazer,
challenge today
transformar
is to transform
esse material
this
na
material
realidade, né, em
in
produtos,
our
fazendo com
reality,
que eles se
in
tornem
real products,
comerciais e
becoming
cada vez mais
commercial possibilities.
com
And
custos
maybe they can be
adequados para
used
que
they
esse
can be
material
used by
seja cada
people
dia mais
and with
implantado em
less
novas
costs
soluções
because it's more implemented
que
in new
sejam cada vez
solutions,
mais
so it
renováveis e
becomes more
sustentáveis.
popular to be
Então esse é
renewable
o
and
principal
sustainable.
desafio
That's
que
the
a
main
Clabin
challenge we have
vem
today
realizando.
as a company,
Eu
and I'm really
gostaria, na
happy to
verdade,
say
de
that.
agradecer
And
agora
with
a
that,
participação
I would
da
like to say
doutora
thank
Juliana
you,
aqui com a
Dr.
gente,
Juliana,
que é
for being here
pesquisadora
with us.
especialista
Our
na
time is
produção e
running
aplicação de
low, and
nanoceluloses e outros
she's a
nanomateriais
specialist of
em desenho e
nanocellulose and
realizando no Laboratório
nanomaterials.
Nacional de
The
Tecnologia
National
e
Nanotechnology Lab
dizer que a
is
gente está
one
disponível
of
aqui para
those
conversar muito
highly
mais sobre
recognized
nanotecnologia e
institutions, and we are
nanocelulose,
here
né,
to talk
Juliana?
about these topics anytime.
Yeah, absolutely, Renato. Thank you.